And today we are starting with LAN wiring, physical topology, and interface hardware, right? So in today's lecture, we are going to start with the introduction. In introduction, what we might have the interface cards. Why a separate card we required? Now, these are the few questions that we might be asking, or that one person has to ask from himself, that why we need a separate card. I mean, without a network interface card, we can have a communication between an outer world with the computer, right? Then how to connect the interface to the computer? Then what is transceiver, right? Then we might have the different LAN wiring schemes, and then we have the logical and physical topology. Now all these things we have to discuss in our today's lecture. Anyways, then we have अच्छा पहली चीज जो अगर मैं I would like to tell you that why we need a separate card. Now see, I would like to tell you that in every computer there is a LAN card. कभी कभी ये भी तो क्वेश्चन ज़हन में आता है ना कि if we don't have the LAN card and if we directly connect our wire, that is RJ45 wire connector जो होता है, that we directly connect with the computer, why we use a network interface card in between a computer and an external world? Now the reason is very simple. The reason is the speed of the network wire. ठीक है, अब इस चीज को अंडरस्टैंड कीजिएगा. आई मीन द स्पीड ऑफ द सीपीयू साइकिल, जो आपके पास कंप्यूटर सीपीयू की एक साइकिल होती है जो गीगाहर्ट्ज में होती है, जिसमें हम कहते हैं ना कि व्हाट इज द स्पीड ऑफ योर माइक्रो प्रोसेसर. ये 5 गीगाहर्ट्ज का है, 6 गीगाहर्ट्ज का है, 10 गीगाहर्ट्ज का है. आई मीन दिस इज व्हाट आई एम गोइंग टू टॉक अबाउट, राइट? एंड द स्पीड ऑफ द नेटवर्क 10 megabits per second, 100 megabits per second. This is the speed of the network. Your speed of the network is always be greater than the speed of your computer cycles or your I mean processor cycle. ठीक है, उन दोनों की स्पीड में डिफरेंस होने की वजह से you cannot directly transform your data without a LAN card inside your computer, or you cannot connect your external wire directly to your computer, and you cannot send and receive the data directly. The reason is the difference between the speeds. अब देखें why it is going to be happen. आपने एक word सुना होगा that is called as bottleneck. I mean where the bottleneck is going to be created. Now see, let's suppose we have a network interface card जिसकी speed है 100 megabits per second, 100 mbps का हमारे पास एक कार्ड लगा हुआ है, and from the back end there is a optical fiber. मीडिया जो है वो ऑप्टिकल फाइबर है. योर डेटा इज कमिंग इन टर्म्स ऑफ टेराबाइट्स, पर टेराबाइट्स में आपका डेटा आ रहा है, और रिसीविंग एंड के ऊपर जो आपके पास रिसीविंग डिवाइस है उसकी कनेक्टिविटी की स्पीड जो है वो 100 मेगाबिट्स पर सेकंड है. डोंट यू थिंक that there is a big bottleneck is going to be created? I mean from the back end the data is coming in a huge amount, and the receiver who is going to receive, or the device that is going to process that particular data, has a very limited capacity, right? Due to that reason a bottleneck is going to be created. I mean एक प्रेशर से चीज आ रही है और आप उसको उतनी वे से या उतने प्रेशर से उसको प्रोसेस नहीं कर पा रहे. ठीक है, तो होगा क्या, आपका डेटा वहां पे स्टॉप होता जाएगा, and it is going to create a bottleneck, and ultimately bandwidth of the network is going to be reduced. The same is going to be happen in this particular scenario. If you are not going to place your network interface card in between your wire and your CPU, ultimately what is going to be happen, आप network interface card को निकाल दें और directly एक हम assume कर लेते हैं, let's assume that your computer's the external wire, that is RJ45 connector जो है, that is directly connected inside your computer without a LAN card. Now what is going to be happen, the speed of the network and the speed of your CPU, they do not match. The network speed is higher and the speed of the CPU is slower, right? Due to that a bottleneck is going to be created. For that reason we need a intermediary device that is called as your LAN hardware, LAN interface, network interface card, or a network adapter, जिसको हम कहते हैं NIC, network interface card, right? Now how to connect this interface to the computer? I would be telling you what is transceiver, I would be telling you LAN wiring schemes and logical physical topology. Now see, LAN data transmission speeds are typically faster relative to the CPU speeds. LAN speeds are defined independent of any specific processor speeds, allows for mixed attached systems. New computers can be attached without affecting LAN speeds. Now see the same thing that I have told you, that जो आपकी LAN speed होती है ना, it is independent of any specific processor speed. हमें नहीं पता कि let's suppose अगर Intel एक प्रोसेसर बना रहा है, उसकी CPU साइकिल स्पीड्स क्या होंगी, ठीक है. अगर आपके पास कोई और कंपनी माइक्रो प्रोसेसर बना रही है, they might have their own speeds. So due to that, your LAN speed and your computer cycles or your CPU speed, they might be different. Due to that, we need a central device or an intermediary device that is called as your LAN card, which is going to manage this speed difference. ठीक है, वो लगाने से आपके पास क्या होगा कि जो डेटा आ रहा है, that is being buffered inside that particular LAN card, and it will synchronize with the speed of the CPU, and then your data would be sent towards the CPU by using that particular LAN card, right? Network interface hardware, CPU can't process data at a network speed, right? Computer system use special purpose hardware for network connections, typically a separate card in the backplane, a network adapter card or a network interface card. I have given you the explanation कि NIC आपके पास यूज होता है. Connector at back of computer then accepts cable to physical network, right? So this is somehow like an I/O interface of your computer. I think if it is visible to you, that's fine. Otherwise, I have to make it large. Okay, so now in this particular computer, or if you can see, that is the bird eye view of this particular computer. Okay, so you may see, ये जो आपको नजर आ रहा है ना, first arrow, this is the socket for interface cards on a motherboard. I mean, everybody have seen this sort of structure of a desktop computer. I think being a software engineer, everybody is familiar with the internal structure of a CPU. ठीक है, ये सबने देखा होगा. ठीक है, opening on back of cabinet align with IO sockets. उसके back end के ऊपर आपके पास openings होती हैं जहां से interface open होता है आपका. ठीक है, ये slots हैं, इनमें आपका interface card लगेगा और back end के ऊपर उसके ports आपको connectivity के लिए accessible होंगे. ठीक है, bus connect sockets to rest of the computer. Now see, these slots जो आपकी hardware slots होती हैं inside a CPU, they are being connected through the buses. जो आपके पास CPU buses होती हैं, through those particular buses, they are being connected with a particular microprocessor, with the internal memory, with the hard drive and all these things, right? So this is what the processor, memory and other components through which these slots are being connected through the computer buses. And I think so you people are a bit familiar with what are the reasons for the buses. Buses are going to take your data from your microprocessor to the components and from the components to the microprocessor. ठीक है, जहां से आपका data internal to the motherboard travel कर रहा होता है ना, that is the main functionality of a bus, right? So this is the structure of a CPU, right? Then this is the back end of your CPU. ठीक है जी, NIC plugged into socket inside a computer. If you can see, this is your NIC that is being installed at your slot, और ये उसका outer interface है. Connector on NIC exposed on back of your computer. ठीक है जी, ये आपके पास बैक ऑफ द कंप्यूटर नेटवर्क का कार्ड आई मीन एक्सपोज हुआ है. ठीक है, यहाँ पे आप अपने नेटवर्क कार्ड को कनेक्ट कर सकते हैं विथ योर कंप्यूटर, राइट? ओके, मेक श्योर आई हैव शेयर्ड दिस स्लाइड ओवर योर फाइल सेक्शन. ठीक है, चेक कर लीजिएगा, वहां पे मैंने अपलोड कर दी थी बिफोर द स्टार्ट ऑफ द लेक्चर, राइट? दैट इज चैप्टर नंबर लेक्चर नंबर 11, राइट? ओके, this is the actual physical representation of your network interface card. ठीक है, you can see this is an interface card. Actually these are the very older computers ना, तो I mean you don't have to bother about, आजकल तो बहुत smart से आ रहे होते हैं, but these are the older shapes, so you don't have to bother, but make sure the structure is the same. अब आपके पास LAN कार्ड स्मॉल होगा, यहाँ पे इतना बड़ा है, इसके अंदर बहुत सी चिप्स लगी हुई हैं. एज द टेक्नोलॉजी इवॉल्व्स, तो अल्टीमेटली these devices are going to be small, right? So this is the slot, this would be inserted in this particular slot और यहाँ पे ये fix हो जाएगा, and that is the back end of your नेटवर्क इंटरफेस कार्ड। ठीक है, ये आपका बैक एंड है जहां से आप अपने वायर के जरिए इसको कनेक्ट कर सकते हैं, राइट। Then this is another special type of network interface card in which there are two slots और ये आपके पास अगर कोई सर्वर टाइप या कोई स्पेशल टाइप ऑफ कंप्यूटर है, for that you have to use this particular network interface card, and this blue connector over here you can connect your straight through or crossover cable or connector over here, and this network interface card would be connected with your computer। ठीक है, ये एक और different structure है network interface card का, right। and okay, NICs and network hardware. NICs is built for one kind of physical network, right? Ethernet interface can't be used with token ring. ATM interface can't be used with FTDI। अब देखें, this is very important to understand। अब अगर मैं आप लोगों से कहूं कि Ethernet interface और ATM interface, they both are different, what does it mean? इसका मतलब ये हुआ कि Ethernet हमारे पास एक अलग से नेटवर्क है, ठीक है, जिसमें हमारे पास बस नेटवर्क आता है और उसकी अपने डिवाइसेस होंगी और अपने आपके पास डिफरेंट सॉर्ट ऑफ स्ट्रक्चर होगा। ATM is something else network and it has its own interface and can't be used with FDDI। Ethernet interface can't be used with token ring, right? So try to understand this particular concept। जो devices आपके पास Ethernet interface के लिए बनी होंगी वही आपके पास Ethernet network के अंदर यूज हो रही होंगी। जो devices which are being used for an ATM interface, they are being used with the ATM interface। That must be clear to all of you, right? So some NICs can be used with different similar hardware। Now see, we might have few NICs which might be used for different but similar hardware। Now what are these different and similar hardwares? We might have thicknet, thinnet and 10 base T Ethernet। Now see, these are the three different NICs which are being using for the similar hardware। अब ये क्या है? I would be telling you, I mean thicknet is for the hard coaxial cable, thinnet is for the smaller coaxial cable and 10 base T is for the UTP and STP cable। लेकिन make sure they all comes under the category of an Ethernet interfaces। ऐसा नहीं है कि हम ATM यूज कर रहे हैं या हम FDDI यूज कर रहे हैं, no, they all come under the Ethernet interfaces but they are different in their structure, thicknet, thinnet or 10 base T, right? I would be telling you in the next few slides, but right now you have to understand this thing inside your mind कि जी हमारे पास हर एक स्टैंडर्ड के लिए उनकी अपनी डिवाइसेस और अपने कनेक्टर्स होंगे which are being used for that particular standard, right? You cannot use Ethernet devices with an ATM and ATM devices with an FDDI and FDDI devices with the token ring networks or something like that, right? So 10 megabits per second and 100 megabits per second, these are the other Ethernet which have the higher speed or something like that, right? So NIC and CPU processing, NICs contains sufficient hardware to process data independent of system CPU। This is again very important thing। आपका जो network interface card होता है ना, it has its own processing power, it has its own smaller CPU, it has its own memory। It will decide whether the data has to be has to be saved at the computer or it has to be discarded, right? ये आपका NIC decide करता है। If it is being destined for this particular computer, it will process it and forward it to the CPU। If it is not destined for the same computer, it will discard the packet at the network interface card level। So that is why network interface card has its own processor and own memory, and it is going to decide all these things at the network interface card level। It would not disturb your normal CPU computer, right, in the normal routine। So some NICs contain separate microprocessor including analog circuitry, interface to system bus, buffering and processing। Look like any other IO device to system CPU। System CPU forms message request, sends instructions to NIC and transmit data, receives interrupts to arrival or on arrival of incoming data, right? So this is how your CPU does work। Now connection between NIC and a physical network, right? NIC stands for network interface card। There are two alternatives। The one is NIC contain all circuitry and connects directly to the network medium, cable from NIC connects to additional circuitry then attached to the network medium. अब देखें ये दो situations हैं. I mean या तो आपका जो NIC है it is directly connected to the network, right? The other one is cable from NIC connect to additional circuitry and then it attached to the network medium. We will be discussing both situations in our next slides, but right now you have to understand these two situations, right? Thin Ethernet versus 10 base T. Both are Ethernet network technologies, not limited to one style of connection. Just difference क्या है thicknet में, thinnet में और 10 base T में, just the style of connection. The style of connectors are different, all other things are the same. अब आ जाएं thick Ethernet के ऊपर. I have discussed with you in the last slide that we have three different types of connection. One is thick, another one is thin, and the third one is 10 base T, right? Now, what is thick Ethernet wiring? अब thick Ethernet आप कैसे create कर सकते हैं? Use thick coaxial cable. I mean, we might be using thick coaxial cable. AUI cable, auxiliary user interface. AUI stands for auxiliary user interface cable, or transceiver or drop cable connects from NIC to transceiver, right? AUI cable carries digital signal from NIC to the transceivers. Transceivers generate analog signal on coaxial cable. Wires in AUI cable carry digital signal, power, and other control signals. Thick Ethernet also requires termination to avoid signal reflectance. Okay. In this particular scenario, this is regarding the thick Ethernet wiring, right? So I would like to explain you all these things into the next slide. If you can look upon this particular diagram, right? You have a single cable, right? Over here, this is your thick Ethernet cable, right? This is your transceiver. This is your AUI cable, which is connected with your network interface card. Now these are the network interface cards, right? Now these are the terminators. अब सबसे पहला क्वेश्चन ये है कि आपके पास ये terminators क्यों लगे हुए हैं? Actually, when your signal is being traveling over this particular medium, that is your thick Ethernet cable, that particular signal when reaches to the destination or when reaches to the end, it must not have to be attenuated. I mean, अगर यहाँ पे हमारे पास टर्मिनेटर नहीं होगा तो आपका सिग्नल डिस्पर्स्ड होके या बैक ऑफ होके अगेन नॉइज जो है that would come again to that particular wire or that particular medium, which will create hindrance over that particular medium. For that reason, we are going to place terminator at both the ends of that particular wire so that your signal must not be dispersed, right? That is the first thing that you must have to understand regarding the terminators. Second thing, what is the responsibility or what is the usage of transceivers? Now transceivers क्या होते हैं? The data that is coming out of your computer, that is in the form of zeros and ones. You may call it as a digital data, right? But your Ethernet cable, that is your thick Ethernet cable, or you may call it as a coaxial cable, always, I mean, data is being traveled through that particular coaxial cable in the form of analog signals. Now, how your digital data would be transformed into an analog signal? That is the responsibility of the transceiver, that it is going to translate or change your digital data into an analog signal over a particular medium, right? This is the responsibility of the transceiver. And then you have the thick Ethernet cable. Now see, this is a bit difficult or a bit different I mean solution and bit complex solution. You have the thick Ethernet cable that is being connected with that particular transceiver. The data is coming from a computer first to the transceiver, and then once it is being transformed into an analog signal, then it is being sent over a media, right? So the two devices, I mean network interface card you have, and then you have the transceiver. ये दोनों devices आपकी लगी होती हैं, and they both are connected with an auxiliary user interface cable that is called as your AUI cable. ठीक है? Then thick Ethernet we have gone. Then we have the concept of thin Ethernet. ठीक है जी? लेकिन thin Ethernet से पहले मैं आपको एक चीज बता दूं, that is called as connection multiplexing. In some circumstances, transceivers may be inconvenient. For example, workstation in a lab. Connection multiplexer connects multiple computers to a single transceiver. Each computer's AUI cable connects to the connection multiplexer. one AUI from multiplexer to Ethernet coaxial cable. Now see, in a smaller situation, I mean, if you have one or two computers, that is fine. You have the thick, you have the transceiver and you have the network interface card, and all are being connected with an AUI cable. But if you have the larger number of computers, let's take an example of a workstation, of your lab. I mean, let's suppose there are 50 to 60 computers that you want to connect. For that particular network, what you need a diagram, something like that. The same network, the same connection, but over here you have to use a connector multiplexer, right? Over here you have to use a single transceiver. In the previous case, what is going to be happen? आपको हर एक नेटवर्क इंटरफेस के साथ एक ट्रांसीवर लगाना पड़ रहा है, ठीक है, जो आपके डेटा को डिजिटल टू एनालॉग कन्वर्ट कर रहा है, और then it will be sending over the network, right? I mean, let's suppose if you have 100 computers, you need 100 transceivers to transmit your data or to transform your data from analog to digital and digital to analog. So this is a bit difficult situation. To overcome this, we have a connection multiplexer, right? जो इस तरह से होता है, I mean, this is your thick Ethernet cable, right? You have a single transceiver, right, over that particular medium, and these are your computers, and in between you have a multiplexer. Now this multiplexer is being connected with your network interface card. The data is being received to these ports of the multiplexer, and from that particular port your data, this multiplexer is being connected with the transceiver with an AUI cable. ठीक है जी, AUI केबल से कनेक्टेड है. अब आपके पास ये सारे का सारा काम कौन कर रहा है? A single transceiver. Transceiver is going to transform your data into a digital to analog and analog to digital, and then send over the media. So this is just the enhanced version of your thick Ethernet. I mean, if you have the enterprise network more than 30 to 40 computers, then you have to use this particular sort of structure of your network, right? Hopefully that is clear to you guys. Then we might have the thin Ethernet wiring. ठीक है, thick Ethernet was clear to you. उसकी दो situations हमने देख ली. अब thin Ethernet wiring is something like use thin coaxial that is cheaper and easier to install than thick Ethernet coaxial. अब देखें, thick Ethernet में आपके पास coaxial cable है that is bit harder and it bit larger, right? It is being used in the thick Ethernet cable. Thin Ethernet के अंदर you might have it is bit cheaper and easier to install rather than a thick Ethernet coaxial cable. Transceiver electronics built into the NIC. NIC connects directly to network medium. So where were we? Right. Yes. For thin Ethernet, we might have the cheaper wires. We might have the smaller thin wires rather than like in thick Ethernet coaxial cable. Transceivers electronics built into NICs, and NICs connects directly to the network medium. कोएक्सियल केबल यूजेस BNC कनेक्टर. अब यहाँ पे ना सिचुएशन डिफरेंट है. इसमें आपके पास जो ट्रांसीवर है ना, दैट इज नॉट ओपन, दैट इज ऑलरेडी बिल्ट इन इनसाइड योर नेटवर्क इंटरफेस कार्ड, राइट? That is not in the thick Ethernet. What you have the network interface card and you have the transceiver apart from that. ठीक है जी. लेकिन यहाँ पे आपके पास क्या है? You have your thick and inside your thin Ethernet, your transceivers are being built in inside your network interface card, and coaxial cable use BNC connector. BNC क्या होता है? BNC stands for Barrel Network Connector. ठीक है, वो आगे चल के मैं आपको दिखाता हूँ. They are being used to connect such sort of Ethernets, thin Ethernets, right? So thin Ethernet wirings, coaxial runs directly to back of each connected computers. T connectors attaches directly to NIC. How? Now this is the structure of your thin Ethernet wiring. Now these are the interface. These are the computers. आप देख सकते हैं कि ये सारे के सारे आपके computers हैं. They have the network interface card. This is the terminator, like the same that we have discussed in the previous slides. And this is the wire, and this is the BNC connector. ये आपका जो BNC connector है ना, that is attached with your NIC card, and this wire, and with this network interface card, and so on, right? This is how your thin Ethernet topology or structure would looks like, right? I think hopefully that is clear. अब यहाँ पे देखें, ट्रांसीवर का कोई कॉन्सेप्ट नहीं है. ट्रांसीवर is already built in inside your network interface card. The only concept is of your barrel network connector that I will be showing you in the next slide how it would be look like and how the network would be structured with your computers, right? So this is how your thin Ethernet wiring would look like. Okay, now see, this is your thin Ethernet BNC connector. ठीक है, ये आपका BNC connector है जो पहला पहला टॉप लेफ्ट के ऊपर है जो हैंड के अंदर है. ठीक है जी, this is your terminator. In the center you have the terminator. I mean the terminator is being placed at the end of both the cables. I mean जहाँ पे आपकी केबल एंड हो रही है वहां पे आपने I mean इसका वो लगा देना है end connector so that your signal might not be reflected back. And this is the T connection or the T connector that would be used. I would be showing you in the next slide how it would be used. This is how your T connector would be used. अब देखें जो बाकी कंप्यूटर से आ रही है wire, this is being terminated over here, the other from it would be terminated over here, and this would be placed inside this computer. तो इस तरह के आपके पास हर एक डिस्टेंस के बाद T connectors लगे होंगे and each T connector is being connected with their individual computer and you have a complete thin Ethernet networks. Hopefully that is clear. Useful when many computers are located close to each other, may be unreliable any disconnection disruption type network. Ultimately unreliable तो है अगर आपके पास कहीं से भी कोई वायर डिस्कनेक्ट हो जाती है for any reason. I mean if it is disconnected from here the whole network is going to be down. ठीक है, क्योंकि it is a Ethernet bus network, so ultimately this is a very big disadvantage. If it is going to be disconnected anywhere from anywhere during the network, it is going to be malfunctioning, right? So that's clear to you guys. This is the physical connectivity. These are the three computers, 1, 2, 3, and these are the barrel connectors, BNC connectors, जो आपके पास connected हैं, and they are being inserted at the back of your computers. I told you these are the older technologies. ठीक है जी, तो thick और thin internet आपके पास older technologies थी. Nowadays we have the 10 base T, जो आगे चल के मैं आपको बताऊंगा. ठीक है, so this is how it would be looks like. ठीक है जी, आपको पता होना चाहिए फिजिकली आपको किस तरह से ये चीजें नजर आती हैं. So hopefully that is clear to all of us. हम मूव करते हैं जो हमारी लेटेस्ट टेक्नोलॉजी है. That was being used in our previous networks. ठीक है, so now we are moving towards a new technology that is called as 10 base T. 10 stands for 10 megabits per second. ठीक है जी, speed of the network. Base is going to show us that what type of communication it is. Either it is a baseband or a broadband communication. And T stands for twisted pair, right? T is the type of media that is being used inside this particular network. This is what you can call it as a T stands for twisted pair. Anyways, so commonly called 10 base T twisted pair or TP Ethernet replaces AUI cable with twisted pair cables, replaces thick coaxial cables with the hub. अब इसमें हमारे पास क्या हो गया है कि हमने AUI को रिप्लेस कर दिया है ट्विस्टेड पेयर केबल्स के साथ, और जो हमारी थिक कोएक्सियल केबल है ना, वी हैव टू रिप्लेस इट विद अ सेंट्रल डिवाइस दैट इज कॉल्ड एज हब. द सेम नेटवर्क दैट इज बीइंग डिजाइन दैट इज बीइंग इन आवर लैब्स इन आवर डिपार्टमेंट, राइट? यू कैन सी हियर आपके पास एक सेंट्रल डिवाइस है दैट इज कॉल्ड एज हब, राइट? All these computers, these are the computers, and they are being connected with this particular central device by using a twisted pair cable. ठीक है जी, and this is an RJ45 connector that is being terminated at the back end of your LAN card or your network interface card, and through them they are being connected with the hub, right? So ये आपका स्ट्रक्चर है. Then you have this is something, अगर किसी ने नहीं देखा तो यहाँ पे देख लें कि this is your RJ45 connector, not a jack. Jack आपका कौन सा होगा जिसमें जाके ये insert होगा, and this is your twisted pair cable. ठीक है जी, ये आपके पास twisted pair cable है. This is your RJ45 connector and it is punched with this particular cable, and finally you can see in this particular diagram this is your RJ45 jack, जो almost आपके पास आपके लैपटॉप्स में भी होता है. ठीक है, because you have to insert your RJ45 cable or RJ45 connector with that particular jack. ठीक है जी, तो this is how it would be looks like, and this is how you are going to insert or put that particular connector inside a particular jack. ठीक है जी, तो is that clear to all of you? Then what are hubs? बहुत दफा बता चुका हूँ, hubs extension of a connection multiplexing concept, sometimes called Ethernet in a box, effectively a very short Ethernet with a very long AUI cables can be connected into a larger Ethernet. I mean, you are going to connect your central device. This is a central device with which all the computers are being connected, but they are not intelligent, they are non-intelligent devices. When the data is being received at the one point of that particular hub, it is going to be broadcasted to all the computers connected in that particular hub, right? इसकी diagram आप देख लें. This is an example of a hub. ठीक है, this is the background back end and this is the front end of your hub के किस तरह से वो connected होते हैं, और ये सारे के सारे कनेक्टिविटीज हैं जो कंप्यूटर इन पर्टिकुलर पोर्ट्स के साथ कनेक्टेड हैं. ठीक है, सो दिस इज हाउ योर हब्स आर बीइंग कनेक्टेड. यू कैन सी द फिजिकल representation of the hubs. Then you have the protocol, software and Ethernet wiring. All wiring technologies use identical Ethernet specifications, same frame format, same Cisma CD algorithms, can mix different technologies in one Ethernet. NICs can provide all three connection technologies. Protocol software can't differentiate among wiring technologies. I mean, Cisma CD, we know that it always been used in the Ethernet, and Cisma CA is being used for the WLANs. We know that, but both are the Ethernet. But CD is being used for the Ethernet and CA is being used for the wireless LANs, right? So these are the three connections. Then we have the protocol software and Ethernet wirings. Now see, this is an RJ45 connector for 10 base T. Now see, अगर हमारे पास 10 base T की connectivity आ रही होगी ना, in the same computer we might be using RJ45 connector for 10 base T networks, right? When we have AUI connector for thicknet, अगर हमारे पास thicknet connectivity है, so we have to use this particular port. And if we have the BNC connector for thinnet, we have to use this particular port. I mean, these three connections are available on your computer. I mean, these are the older computers. अब तो आजकल आपके पास just RJ45 10 base की connectivity होती है. We don't have the thicknet and thinnet connectivity, but in the older computers we might have these connections. So if you want to connect your network computer with a network of thicknet, तो आपने ये central वाला port use करना है. If you want to connect with via thinnet, you have to use a barrel connector, and if you want to connect with your 10 base T network, you have to use an RJ45 connector. Hopefully that is clear to you guys. ठीक है जी. Comparisons of wiring schemes, ये अब इनका वायरिंग स्कीम्स का कंपैरिजन है, ये आप लोग पढ़ लीजिएगा. कंपैरिजन वायरिंग स्कीम्स कौन सी, तीन वायरिंग स्कीम्स कौन सी हैं? 10 base T, thicknet and thinnet, right? I have told you that thinnet is being used where? When we have the larger set of computers. Thicknet are being used where do you have the smaller number of computers. And 10 base T is a very generalized network that is being used everywhere nowadays. We have this STP and UTP cables, and they are being connected with the network interface card, and we do have the central device that is called as hub, which is going to connect all these devices with your computers, right? So this is just the comparison. अगर इस diagram को आप देख लेना तो ये सारी चीजें आपको clear हो जाएंगी. वायरिंग स्कीम्स, ये जो ऊपर वाली वायरिंग है ये सारी की सारी आपके पास थिकनेट की, दिस वन, राइट? एंड दिस इज फॉर द थिननेट, दिस वन, दिस इज फॉर द थिननेट, एंड दिस इज फॉर द 10 base T. ठीक है जी. द लास्ट वन, द A इज फॉर थिकनेट, B is for thinnet, and C is for I mean to say that 10 base T sort of network, right? Where you have the hub and all the computers are being connected with that particular hub. Here we have the BNC connectors which are being connected with each and every computer, and that is BNC connector. और अगर आप पहली A diagram को देखें तो you might have this connector, and you see these are the I mean to say that transceivers. ये आपको सारे transceivers नजर आ रहे हैं. जो आपके पास smaller rectangles हैं ना, they are going to be shown as a transceivers, and you have the network interface card, and they are being connected with the transceivers, and transceivers are going to translate your data from digital to analog and analog to digital, right? So hopefully that is clear to you guys. Then you have the topologies and network technologies I have discussed with you, and this is a summary.